Okay, so you want to design your own circuit boards and you need a bit of software. Well, for me, I use KiCad. It helps me visualize all of my circuit boards. Just to say, this isn't affiliated or anything like that. But I use KiCad as my PCB design suite, and it really is quite a beautiful piece of software. But you're not going to use, as a hobbyist, most of the functions. But as you can see on the screen, this is where you can download it from, KiCad.org, and then you just hit the download link for whichever flavour of operating system that you have. I'm on a Linux machine running Pop OS, so I've already installed it. I didn't install it from here. I actually went to the Pop OS Cosmic Store and I just typed in KiCad and it's no longer coming up because it needs to refresh before it does anything. There we are. After a moment it will come up, and then I just installed that one. So there you go. That's simple enough. Right, then you're going to get hit by all the setups and just basically install the basics, because you're going to have to put extra libraries in. But once it's set up, you will come to this, and then it's like, oh my goodness, what do I do? Now you go File on the main screen, File, New Project, and then you'll have a template. So do you remember I said that there was the Arduino Uno there? Well, let's make it a Uno project. I mean, you can do all of these ones, but we're working with Arduino Uno. And then we just go OK. And then we'll give it a name, video project. Let's say. I know I haven't spelled that correctly. Never mind, eh? Right. So in video project, we'll go to the schematic editor. Now, when we said it was an Arduino Uno project, it's automatically given us this, which is the pinouts for an Arduino Uno, and it's also the footprint, which is quite important if you were to be making a shield, which is the part which just clicks on the pins and goes over, and then it's just like a one-stop fix, which you might well be making. So with this, we have the pins, which are exactly the same and look exactly the same as on the Arduino Uno. If we were to save this and we go up to this one here, which is switch to PCB editor, you can also get to PCB editor here and here. We can click it from here and you'll see it takes a moment. It automatically brings you up an Uno. So that is your footprint. That's what they call the footprint of your design. So inside the Uno, you've got all this space around here. And that's what we're going to want to use just for this video. Let's wire up a blinking LED for a test project, should we? Okay, wiring up our LED. This is our Hello World sketch of the physical world and electronics to make sure our board is actually working. So we want to connect up an LED, so we go back to schematic because we need to add it to our project first. Now we want it to come out of pin 6 and we want it to go round to ground. So in the circuit we are going to need an LED and a resistor. For an LED, which is what, 1.8 volts maximum forward and 15 milliamps. We are looking at having, and the Uno kicks out 5 volts, so it's 3.2 volts difference. We want a 220 ohm resistor. So what we will do is we will go and get our components from here, the place symbols, left click. You want the CQY99 LED. Just for this project, you might want a different one, a specific one from a different library. But for this project, the important thing I'm looking at here is it's single direction, and it's 5mm pin pitch, which is standard pin pitch for like perf boards and general handy projects. If you want to go really small, you might find the 3.2s and 3.6mm. They're not going to fit in a perf board, so be careful of that when you are going to 3D print your circuit board. But anyway, here we are. We do this and we go OK. We'll put it down here for simplicity, and then we'll go back to symbol editor. Oh, right. Okay, so you can right click, cancel, and then you can go back up here, resistor 220, and here you have 220-0402. You only want a single resistor. This is my recently used, which is really a really handy feature of this software, because when you're doing things like Arduino, you're doing LEDs, well, you're always going to want a 220 ohm resistor. But when you search it, these are your search results down here. But I'm going for that one. I'm going to lift this up a bit so I can click OK. I'm going to pop a resistor in front of it, and now sometimes that works, sometimes it doesn't. If it doesn't work, then click cancel and then cancel again, and then whatever you standard highlight and delete. Okay, so to make the circuit, next is you get the line there. You might need to zoom in depending how good your eyes are or your screen. Then left click out here to make a corner, sort of in line there, and make a corner. When it's a nice line like this, the circuit is made. Then we click on, if there's a circle like around here, there is no circuit made, so it's an open end. So we click on that one to there, and notice how the circles have disappeared. Now I use the middle mouse button push down to pan the screen across. We need to now go from the output of this resistor to the ground. If I just select left click the ground button, the circle there, and I come down here, it's gone all the way across those lines. Now I always like a bit of management on this, so I come out, I left click there, and then I'll come down, because I don't think the auto routing works very well on it. It works about 60% of the time. It will find you a good route. That's nice and clear to understand. Otherwise, just left click a little bit, pull it out, left click, and it'll auto route from that point. So anyway, that's all good. I'm just going to try and come out of line mode. There we go. It's no longer in line mode, and I can do things like that and just select, right? Otherwise you could pop a line down somewhere, and that's gonna make your circuit somewhere else and then cause a problem. Right, okay, so that is our basic circuit, all made out. That's a good schematic. So if we now go to PCB layout, we will have this button up here, update the PCB from schematic. Now this can be tricky. It's really easy. You just push the button and update PCB. That's not the tricky bit. So here we have, do you see that blue line that's attached to it? That's telling me that that is connected to that pin in the schematic. Now in here, I do believe it's bunched them together. What's the pad? No. R1 footprint. We want to move that. So sometimes it bunches them together like that, which isn't, it's not overly pleasant, but you can quickly just move it around, right? Not a problem. So now we have our pin 6, and it's telling you which pin it's connected to. The circuit then goes to a resistor, it then goes to the LED, and it then goes down to ground. Now we need to actually make tracks so that they can print them, or if you're going to stay around for the next bit, then we will 3D print this, and then use copper sheet to make our own circuit. So following these tracks, it's important to note these tracks here, this is already done on the Uno. Okay, so ground pins are all connected in the Uno. This is SDA and SCL, and same there. Interesting to note that they swap over direction. So if, for instance, you can't get a circuit on because of the circuit tracks, stick it on the other side of the board, and rotate it or whatever. Anyway, getting back to this, we're going to select multiple tracks because we just basically want to go from here Oh, I know what's happened. So it thinks we're on there. Okay, it's using the footprint of the board. Okay, so what we're going to do is we're going to actually get, rather than get all complicated, we are going to push escape, get out of that, and we are going to move these because it's designing it for a Arduino Uno hat, which is going to sit on top of the board, isn't it? So what we should do is we shall move those to there, and this is just so that you can see how the software works, so I'm not that worried about it. There are ways that you can redesign your whole board and say, my board is now this big, but I'm using a template for this. So we're going to go to tracks, there, we're going to zoom in. Oh, sorry, I didn't talk through that. Okay, so now we have a track here that comes from here. I don't particularly like this track, so I'm going to go select. No, I want, if you go, that's a lasso select. You just come back out of it like that. If I select here, I can manipulate the track, how it comes out. And if you were to say want to, you could even make some weird shapes with it. But I like that. That's not too bad. That'll be easy to cut out. Now, if you were to double click, then you get the track properties. Now, the things that I want to draw your attention to on this is the over here. This is your layer. Are you going to have it on the front of the PCB? Is it going to be on the back of the PCB? So if you were, for instance, soldering things on this side of the board, you want your tracks on the back of the board. If you were to, say, be putting big components on that there isn't enough room between the Arduino and the board, then you want them on this side of the board and the tracks on the back. But you may want this side to be flush, so you'll put your tracks on this side and the tracks on the back. Tracks on this side and your components on the back if they're all small little components, for instance. Now, here, this FCU, if you think of it like front copper, because CU is copper, right? F is for front, CU for copper. So that's your copper layer, right? That's where your tracks are going to get made, is in the copper. So FCU is this side that you're looking at here. BCU is behind the board, the back copper face. Okay. Now I use back copper face and I stick the components on the front when I make a board. That's absolutely fine. But whichever way works for you. But if you need to swap tracks, you don't need to redesign the board in reverse. You just change it whether it's on the front side or the back side. Okay. There's also settings where you can drill holes and put, the holes come through if you were to send your PCB off for a double-sided board, and things like that. So that's really good. It's really, really a good package, this. Now, track width. I don't do 0.25 because I 3D print my circuit boards and then I put a copper film on the top, as you'll see in the next video. I'll show you how to do that. But I make them 1mm. Put my num lock on. I make them 1mm wide. That's enough for pretty much most projects, and you can generally get away with it with the film and everything like that. And also, if you were to multi-select, you can do, I think, up to about 10 lines. Now I'm going to get to the same menu by pushing E. Okay, and I'm going to select that to 1mm. Still going to use the FCU because it's only for this one. In fact, yeah, we'll leave it at that. So they come out of there. Now, if I was to bring another track, this is the 1mm thing that I want to tell you about. If I bring another track out of there, and I come to here, all right, and then let's run it back to here. No, let's not. There you go, cancel. We go like that, and when because we're using all of the pins, right, we want everything like that. So now if I multi-select this, push E, and I'll set that to 1mm. It's getting close, isn't it? This is the sort of gap here that you will be able to work with your copper film. If I then go and make it 1.5, and I have experimented with this, this is a really good tip. And I go E, change that to 1.5. Even if I were to move this up, this gap here, right, is just too small. You won't, when you're 3D printing a circuit board for a copper film, right, that is too small. There is not enough room for you to get your podger in or your tweezers to actually make that without damaging the track. So that is why we do this at 1mm, and we stick to that, because when they come out of it, when you're over here, make them as big as you like, but when you have to make the tracks in here, it's just too close. Now I've selected something else there which I don't want to delete, so I'm just going to do that. Okay, right, I am aware this video is running on a little bit, so I'm going to make this track here. Do you see this blue line here? That tells you where you have to put your track. So from that one to there. Okay, so now we've talked through that, let's export our PCB ready for 3D printing. File, we go export, and then we want this step blah 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 STL. Okay, now you may find it's not set up in step this, that, the other. It might well be defaulted to step. Come down in the drop down menu to STL. You want export board only. If you export all the components, then you're going to get like a 3D model, which is great if you were to be making it for a video game or something like that, or a project, and you wanted a 3D visualization. So then you'd export all the components, but we are just printing the circuit board, so we want it as just one piece that we're going to print. And ideally we'd like to send it to the printer. You could send this off to, because it's an STL, you could send it off to your printer slicing software and do it that way, but the problem I find is that the holes can quite often be too small, so I bung it into Blender first. And here we're going to go, I've already made the, we want it as a .stl, not a .blah blah blah. So I've named it video LED.stl up here. This is your file finder, folder finder, and all that good stuff. So save that. Then we want to export. Now, if we go over to, that says success there. So if we go over to Blender, just so you know, if you leave this file open and you go to use anything on KiCad, or you get an unresponsive KiCad environment, then you are generally finding that you have a window open and it is waiting for that window to be closed. It's not like every other. This window's okay, but you won't be able to do anything with other windows and things like that if you have windows open that are more advanced. So you're in this window and you're stepping forward to export, right? If you leave this window open, because it's waiting for you to finish this function and close this manually before it will do anything else. So if you find that KiCad isn't responsive, just make sure you haven't got any windows open or anything like that. I'm going over to Blender. Now, delete that. Okay, right, so file, import, STL, and here we have video LED.stl. If you ever find that it doesn't import the .stl, make sure that it is just ending the export with .stl on the end and not .stl step and all of that good stuff, as you saw me delete there. So import. This is our circuit board that we have not just designed. This is the circuit board I designed earlier. So let's import STL, video led.stl, import STL. That's better. Now it may be hard to see, but there are actual tracks there, as you can see there, right? Now they look like they have been reset to the 0.035 and not 1mm tool. You know, right, okay, so what we can do with that is we go to KiCad, we save this, board setup, physical stack up. Now do you remember I said you need to know which face you are printing on, whether it's front face or the back face? So these were red, so it's the front face, so front copper. And sure enough, it has reset it to 0.035mm, which is great for a PCB that's being etched. But for us, we need it to be 1mm thick on the actual plate, so we can actually cut the copper out. So that is okay. And then we have to save it. If we don't save it, all of that just stays in the memory, but it doesn't update what you need for exporting. So we save there, and then we can export. If we don't save it first, then you'll just get the same output again. Okay, so what I'm going to do, I'm going to use the same video thing, except I'm going to go on the end 1mm. Everything else has stayed the same. Export. Done. Blender. I'm going to move this along G. So I'm just grabbing it down the X. I'm going to put it there. Right. File. Import. STL. And we're going for the 1mm. Import STL. And now you can see the tracks. They will actually print nicely like that, right? So you can change your track height. Exactly the same circuit. Everything else. Tracks are different. Now, if you see here, right, we've got no holes. Now, if you were to want to print those holes, that's great. That's not great. I mean, you'd have to drill them. So what I do, now everyone has their own techniques. So I go add, mesh, cylinder, and I make my holes 2mm because that's a standard pin, like 1.9mm or something like that. But they push in nicely when you get the tolerance for the 3D printing. I shall grab that cylinder on the X and I will period button, as many people call it, is to focus. Do you see here? You know, it's not all perfect, is it? That line there, that's not 1mm wide, is it? So you can sort of inspect it before you go out. For me, not such an issue. This is just a tutorial, but if I was printing this, I would go back in and I would adjust that line in KiCad. But gee, I appreciate you all got lunch to have. I'm going to push number 7 on the keypad so I get a vertical view, because I know where the track is and I just want to make that hole bigger. So GX, GY, it's roughly about there, right? Then I will select the actual board. Where's the board? LED 1mm, that's that board. I'm going to come down here to modifiers, add a modifier, Boolean. Now this is updated somehow, but I select that one there, and then I want my cylinder. And then if I make the cylinder invisible, oh, hold on. Ugh, typical. I haven't adjusted the size of the cylinder, have I? Let's have a look. No, the cylinder's about the same sort of size, isn't it? Oh no, it's not long enough. Look, it's not long enough. Okay. Oh dear, what a boo-boo. Right, so with the cylinder selected, we want, which one is it? Is it Z? There we are. That'll do. It doesn't have to be perfect. It's only to make a hole. GZ, so it comes up and it covers that, because you want the hole to go the whole way through, don't you? Because you've got to put pins through. Okie dokie. Now, if I make the cylinder invisible, there we go. We now have a 2mm hole. That is going to be perfect for our components. So now I'll quickly just blitz through and I'll quickly upgrade these holes, and I'll be right back in a moment. Okay, now that is beautiful-ish. These might not be the exact spacing, but sometimes you just have to measure it and this, that, the other, and go for it. That could probably be further over here. It just depends what the pins are, but for a tutorial point, it's there, right? You get the idea. Now you can actually print that. You can export that as an STL to your slicing software, and there you go. You've got your own 3D printed circuit board tracks. But anyway, that's how you can print out a nice, lovely LED circuit.